Hey, this is Mr. Ward, and I'm doing a video key for exit ticket 21.2. And the questions are pretty similar to the do now, so hopefully this will work for you. So express this as a power of 10, 1 over 1,000. Well, 1 over 1,000 is the same as 1 over 10 to the third power. So if that's 1 over 10 to the third power, remember that negative exponents give us divisors. So we're dividing by 10 by 10 by 10, which means that that is the same as 10 to the not positive 3, but negative 3 power. I'm going to put it in parentheses, and I don't have to do that, but because of the format of this, it is a little clearer to do that. Now, let's move on to the next question. Express this without using any negative exponents. Now, I've said several times in class that if you move a base across the fraction bar, you change the sign of the exponent. Because right now, we've got a numerator that is saying n is going to be used as a divisor 5 times. But that's the same thing as saying n, if we put n in the denominator, it's being used as a denominator factor 5 times, since denominators are dividinators. So we can move that n into the denominator. The v to the second power in the denominator can stay right where it is. So it's going to be 1 divided by n to the fifth power, that's 5 to the fifth power, times v to the second power. And I put that in parentheses so it's really clear that all of that is the denominator. If I were writing this vertically like this, I'd say 1 over n to the fifth power times v to the second power. So what this is really saying is I'm using n as a divisor 5 times and v as a divisor 2 times. It just happened to be in a numerator position here, but once I moved it across the fraction bar, the sign of the exponent changed to positive. So let's take a look at number 3. We have c to the 12th over c to the 15th. Now, if we were to write this as a fraction, we'd have c, etc. We'd have 12 of those. So that'd be 12 factors of c, ... right? And then over here, I have 15, but 15 is the same as c times c times c. That's 12 plus 3 factors of c. I'm not going to write it all out because it takes a really long time to do with this program. So 12 plus 3 factors of c in the denominator. And we can factor 12 of those factors of c out here and 12 of those factors of c down here, and we're left with 3 in the denominator. So here's how I could write it maybe a little quicker. C to the 12th, and then down in the denominator, we got c to the 15th is the same as c to the 12th times c to the third. So these 12 and these 12 go away, and we're left with 1 over c to the third, which is, of course, the same as, since that's a denominator, since it's a divisor, that's if I move that across the fraction bar, I can put a 1 down here to make it really clear that I've done that. That's c to the negative 3. So I'm going to put a 3 here, and the sign is negative. So when I move this across the fraction bar, the sign of the exponent becomes negative. So I could write this as c to the negative 3 or 1 over c to the third. Now, the quotient law would simply say that this is c to the 12 minus 15 power, which is of course c to the negative 3 power, or 1 over c to the third power. Both of those are fine answers. So the answer ends up being c to the 12 minus 15 power gets us, I'm going to put that all here to make it hopefully much clearer. The quotient law says we subtract the exponents when we're dividing, and that becomes c to the negative 3 power, which is, of course, the same as 1 over c to the third power. Either of those answers would be fine. All right, let's move on to the last one, number 4. Number 4, I've got negative 2 factors in the numerator, negative 5 factors in the denominator. One way we could think about this is, of course, the quotient law. The quotient law would simply say m, since they're both the same base, and since we're dividing, to the negative 2 minus negative 5 power, which ends up being m to the third power, because negative 2 minus negative 5 is the same as negative 2 plus 5. So that's m to the third power. So that's one way to think of it. Another way to think of it is if I move a base across the fraction bar, the exponent's sign becomes positive. So I'm just going to move m to the negative fifth up here and make it m to the positive fifth. And that's the same thing. And this m to the negative 2, I'm going to move down here and make it m to the positive 2 power. And so that becomes pretty clear. We're going to have 2 factors of m down here and 5 up here. I'll be left with 3 once things get cleaned out. So because m to the fifth is m to the third times m to the second. And that's all over m to the second. And these will cancel out, leaving me with m to the third. And so that would end up being m to the 5 minus 2. So this is just ways of rearranging it so that things are a little easier. 5 to the minus m to the 5 minus 2 is just m to the third. And so our answer is, of course, m to the third power. So there are 3 factors of m here. So it ends up being m to the third power. I hope that helped.